Alright, so today in this lesson we are going to deal with the distance formula. Alright, the distance formula is not that difficult. It's basically another version of the Pythagorean Theorem, you know, like c squared equals a squared plus b squared. Alright, so for example, let's look at this diagram right here. And can you tell me what the distance from A to B is in units? Well, for example, we have 1, 2, 3, 4, 5, 6, 7. So the distance from A to B is 7 units. See, horizontal distance is very easy to calculate. Now, what about CD? What do you think the distance is? Well, let's see. 1, 2, 3 is 3 units. Now, what about EF? Yep, not so easy, right? So, what you can do, the approach that you can take in case you ever forget the distance formula is you could create a right triangle. You see this? You could create a right triangle right here. So then we count the units. So let's call this A and let's call this B, and of course the hypotenuse is always C. So A is nothing more than 1, 2, 3, 4. So this is 4 units. B is 3 units. Okay, 1, 2, 3. And now we use the Pythagorean theorem to figure out the hypotenuse, which is the length of EF. Well, the Pythagorean theorem says C squared equals to A squared plus B squared, right? So now C squared is what I don't know. Then A squared, well, A squared is 4. A is 4, so A squared is 4 squared. Plus B, which is 3, so B squared is 3 squared. Now, what happens is that C squared is equal to, and now 4 squared was 16. Plus 3 squared is 9. So C squared is 25. Alright, now thing is this. I found C squared to be 25. Unfortunately, I don't want C squared, C to the second power. I just need C. So the way to undo something to the second power is to take the square root of that. So then look at what I'm gonna do. I'm gonna take the square root of C squared, and this, of course, what you do to one side, you do to the other, and the square root of 25, making C equal to 5 units. Okay, so that's it. All right then. So now let us talk about the distance formula. The distance formula works however the line is tilted, okay? However slanted the line is, it works all the time. So let's look at the distance formula. And by the way, distance, I just want to say something. The distance here. Distance is achieved by the difference in coordinates. For example, look at A. A is at -4, right? And B is at 3. So what is the difference between -4 and 3? Well, easy. -4 and then the difference, meaning the subtraction, right? So -4 minus 3 is -7. But since distance cannot be negative, then we take the absolute value of -7, which is +7. See that? That's how it goes. Same thing here, okay? We figured out that the distance was 1, 2, 3 because we use our common sense and we were able to just figure it out. But in reality, you do this. So since this is on a vertical distance, then we're talking about the y-axis. So -1, and this one is -4. All right, so let's see what happens. -1 minus -4, the difference in coordinate, this one and this one, okay? -1 minus negative, remember what I said about having two signs? Just multiply them and you get the ending sign, the resulting sign. So negative times negative is positive. -1 plus 4 is 3. In this case, the 3 is positive, so I don't need to take the absolute value. But remember, distance is always positive. You're not going to say, oh, let me drive to Washington, it's 500 miles. Wait, let me drive from Washington back to New York, and now it's -500 miles. No, it's still 500 miles, however you do it. All right, so let's see if we can come up with a strategy to remember the distance formula. So we have the same diagram right here. So the distance formula is nothing more than, and we have it right here. The distance formula is nothing more than the Pythagorean theorem written in a different way. For example, remember that C squared, look, C squared equals to A squared plus B squared. But if I was to really just remember what I need. I need c, not c squared. So to obtain c, I have to take the square root of this one, and what I do to one side, I do to the other. So remember that. So of course, the square root of c squared, in this case, they call it d for distance. And then this part is the one that never changed. Remember what distance is, the subtraction in coordinates. So that's all I did. Subtract the x's, you see, and square them because that's what the Pythagorean says. Plus, and then b squared. What is b? The subtraction, okay, the difference in y coordinates. So that's what it is. So there you have it. The distance formula, subtract the x's is the square root of the subtraction of the x's or differences of the x's plus the difference in y and then square. All right. So then let's see how it works. Let's find the coordinates of E. E is 1, -1. Okay. That's what E is. F. Well, F is nothing more than 1, 2, 3, 4, 4, 1, 2, 3, 4, 5. This is 4, -5. That's what it is. All right then. So now let's label them. Let me zoom out a little bit. So let's see if I understood. The problem here is a x2 minus x1. So I'm gonna make this x, y, x, y. In the problem, these are the ones and these are the twos. Okay? So now let's see. x2 minus x1. 1 minus 4. See, 1 minus 4 squared. Plus, and now the difference in the y's. Remember something, you've been doing this all along. It's like the difference in x's and difference in y is like when you were doing the slow formula. But anyway, this is different. So y2 minus y1. y2, which is -1, minus from the formula, and then the other y component, which is -5. And then square. And then just do third grade math. So 1 minus 4 is -3. Square, okay, -3, sorry. Plus -1 minus -5. Minus -5. Minus negative means positive. So -1 plus 5 is 4. Square. Oh, nice. Now -3 squared, any number squared. That's why when you put it in the calculator, make sure you put it in parentheses if you have a negative number. Because if you don't, you're going to get a negative answer. And any number squared is positive. So -3 squared is the same thing as -3 times -3, which is 9. 4 squared is 4 times 4, which is 16. 9 plus 16 is 25. Oops. Sounds like what the same thing that we had before with using the Pythagorean theorem when we created the right triangle. So we take the square root of 25 and the answer is 5. So the distance here is 5 units. All right then. Now, before we embark into these problems, I need to explain to you what radicals are. So let's have a mini lesson on radicals. Okay, so take notes. So radicals. What's a radical? Nothing more than a number inside a square root. So radical 4, square root of 4 is 2, correct? Now, the square root of 9 is 3. How about the square root of 50? Okay, the square root of 50, if I use the calculator, right? If I use the calculator, I go second, okay, second, and press x squared, so you see the square root symbol right there. And now we have it here, 50, right? Now when I put it in the calculator, it says 7.071 and blah, 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 blah. It's an infinite number. Guess what? If the question asks you to leave it in radical form, you cannot write 7.071. No. That means that your answer will have at the end a radical. So let me explain to you how to simplify radicals. Let's start by the perfect squares. Perfect squares, okay, are numbers that have square roots. For example, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. If you cannot memorize this, if you don't know, if you're wondering where I got these numbers from, let's count from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's square these numbers. Okay, and now look at the result. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and so on and so forth. Basically, and these are the basic numbers that you need to memorize. You could count to 20 and you'll get the rest of the perfect squares, but for now, there's no need. So let's go back to radical 50. Radical 50, how are you going to simplify it? Easy. You're going to find the largest perfect square. Okay, you're going to find two factors. One of them being the largest perfect square. So 50 is nothing more than 25 times 2. This is 50, but now radical 50 is radical 25 times radical 2. Hopefully I make myself understood. And now, what is the square root of 5? I mean, of 25? 5. 2 doesn't have, there is no number in here that is going to give you 2. So it stays the same. See that? Let's do another one. Let's say I want to simplify the square root of 72. Okay, 72, I understand that this is 36 times 2. So 36, the square root of 36 is 6. Radical 2, as we said, doesn't have. Okay, how about radical 75? How about that one? Well, radical 75 is the same thing as 25 times 3. See that? So radical 25 is 5, and 3, there is no number when you square it, you get 3, so it stays like that. All right? And you have little examples, radical 125. If you want to practice, try this one, radical 125, radical, I don't know, oh my god, let me see now, radical 12. Radical 12 is one of the common ones. 12 is nothing more than 4 times 3. Okay, if you say 6 times 2, it's fine, but you won't be able to do it because there is no number that squared gives you 6, or when you square it gives you 2. So no, so that's why we have to choose 4 and 3. All right, so that was the quick mini lesson in radicals. Let us get back to the thingy at hand. So let's see now. A line segment has endpoints of 4,7 and 11, and 1,11. What is the length of the segment? Sure. So the distance formula is, right? Okay, let me see now. Oh, okay, got it. Gucci. Better. All right. So is subtract the x's, x2 minus x1 or x1 minus x2, I really don't care, but you gotta follow the same order. So y2 minus y1 square. All right, so now you label this, right? This is x, this is y, just like when we were doing slope, x, y. Let's call this the 1s and let's call this the 2s. So let's see now, x2 minus x1, so that's 1 minus 4 squared plus 11 minus 7 squared. Okay, so now let's see what we get when we do the third grade math. Okay, 1 minus 4 is -3 squared. 11 minus 7 is 4 squared. Okay, so now -3 squared is 9. 4 squared is 16. We already know what this is going. This is radical 25, and the square root of 25 is 5. So the length of the segment is 5 units. So our answer being choice number 1. Of course, you circle the choice. If you don't, you're gonna get it wrong. All right. What is the length of the segment right here? Well, these are the endpoints. So this is x, this is y, this is x, this is y. Remember to follow the same order. I'm not going to label them 1, 1, 2, 2. I'm just gonna call the first point that I see the ones and the second point that I see the twos. All right, that's all I'm gonna do. So let's see now. You already have your distance formula. So let's see now. x2 minus x1. So x2, which is 9, minus 1 squared, plus y2 minus y1. So it's 2 minus from the formula, and then y1, which is negative 4. And then you square the whole thing. And as you know me, I'm going to start skipping steps. So 9 minus 1 is 8. Square 64. 2 minus negative 4 is 6, because this turns into a plus sign. So 6 squared 36. I'm still showing my work. It's just that I'm skipping certain steps that I feel are unnecessary once you get the hang of this. All right, 64 plus 36 is 100. So that's it. The distance is 10. And making your choice, pungum. All right. Okay. Next problem. What is the length of the length? What is the length to the nearest tenth of the line? Oh, sorry. What is the length to the nearest tenth of the line segment joining the points? These points. All right. So this is x, y, x, y. I'm gonna call this the ones and this the twos. Okay. So the distance formula, I have to subtract the x's. So x2 minus x1, which is negative 4 squared, plus y2, 52, minus y1, which is 2 squared. Okay, for this I really need the calculator. Well, not yet. So 146 minus negative 4. In other words, 146 plus 4. That is 160 squared. I have not done the squaring. Plus 52 minus 2 is 50 squared. Guess what? I'm not a genius, so I need the calculator. And it's to the nearest 10, so let's see. What is 150 squared? 150, okay, square. What is the square button, Becker? The one that reads, wait, it's blurry, let me fix it. Okay, this one is the squaring button, okay? Oh, okay, got it. So 150 square is 22,500. Oh, okay. And now 50 square is 2,500. So then, let's see, 22, so I'm going to write distance equals and then square root. So 22,500 plus 2,500. Okay. Oh, by the way, can you do the distance formula, the whole formula inside the calculator? Of course you can. You want me to show you how? Since we already, no, let us finish this first. All right. So what is 22,500 plus 2,500? That's 25,000. 25,000. And now what is the square root of 25,000? 158. The distance is 158.113883. Okay, so I'm supposed to round to the nearest tenth. Okay, so this is 158. After the decimal point, we start counting. This is the tenths, the hundreds, the thousands with th at the end, to the nearest tenth. So go to the tenths, look to the right. If the number that you see is 5 or more, the 1 becomes a 2. If it's less than 5, then it stays at 1. So your answer is 158.1. Got it? Whew. Oh, if I could do the whole thing on the calculator, sure. Let's see if I can do this. All right. So I had 100 and let me see if I can do it. 100. Okay. First of all, I do the square root. the square root, and then I put parentheses. And I said 146 minus -4. See, the minus and the negative are different. Square, right? Plus, okay, 52 minus 2 squared. And now let's see what we get. Boom, same answer. Oh, Becca, you gangster, MLG, of course. All right. What is the length of the segment with endpoints? And look at your choices right here. They're all radicals. Okay, radicals, just in case you don't understand that. So let's do it then. Okay, so we already agreed that ones and twos, right? Okay, so x1 minus x2 squared plus y2 minus y1 squared. Okay, 2 minus -6 is 8 squared, and then -5 minus 4 is -9 squared. Distance is 64, okay, plus 81. -9 squared is 81. All right then, so what is 64 plus 81? Okay, that is radical 145. So, ways to check if this is your right answer. Definitely it's not going to be radical 13 because it's less than that, but it will have to have another number outside. It cannot be radical 72 because then it needs another number outside. And it cannot be radical 17 because it would need another number outside if it was to be somewhere, something like this. So your choice is this one. Now, you want to make sure that this is correct. Then what you do is try to see if you can simplify radical 145. Well, numbers that end in 5 can be divided by 5, okay? But let's do it. So how do you do it? Easy. This is the proof test of fire. 145 divided by a perfect square. So I'm not going to divide by 1 because then I'm always going to get the same number. So I'm going to divide by 4. Look, I get nothing. This is not what I need. I need something perfect. Okay, 145 divided by, what's the next perfect square? 9, right? Nothing. 145 divided by the next perfect square? 16, nothing. 145 divided by 25? Nothing. 145 divided by 36, that's the next perfect square. And I get nothing. And if you keep on trying, look, 145 divided by 49? Nothing. 145 divided by 64? Nothing. 145 divided by 81? Nothing. And please, the next one is not gonna be. So that's one way of testing. Now, how do I know that? Easy, because when I gave you the example of radical 75, look, 75 divided by a perfect square like 25 is 3. So you know that 25 and 3 are the factors, and that 25 has a perfect square root. All right, if you have any doubts, you can always ask me. All right, last page for this packet. Oh my God, this is awesome. All right, what is the length of the line segment? You know what? No, you do this page, okay? This is the ones, this is the twos, right? Okay. 8 squared is 64, and negative 10 squared is 100, so this is 164. All right then, now it don't look like I have anything there. Now, the square root of 164, let me tell you something. The square root of 100 is 10. The square root of 144 is 12. The square root of 169 is 13, so this is close to 13. Radical 2 is not going to be 13. The square root of 10 is not going to be 13. 2 times the square root of 2 is not going to be 13. Now, the square root of 41 is closer to 7. It's around 6 point something, because the square root of 49 is 7. So 2 times 6 point something should be close to 13. But anyways, one way of doing it, remember, is to divide 164 by perfect squares to see which one it is. So 164 divided by 4. Oh, that's it. Wow, 41. Okay, so this is nothing more than 4 and 41. That's 164. You see how I did it? The square root of 4 is 2. A square root of 41, there is no number where when you square it, you get 41. Because the number before this is 36. And the number after this is 49. So 41 doesn't have. So this is your correct answer. Boom, bada bing, bada boom. Okay, let's move on. Okay, what is the distance? Once again, I got radicals. I don't have a problem with that. Not anymore, correct? So let's see, the 1s and the 2s. So x2 minus x1. One minus negative 3 is 4. Square, 16. Plus 0 minus 2 is negative 2. Square, 4. 20. You see that? Now 20. There's no 20 here. You could figure out what 20 is on the calculator. It's going to give you a decimal, and then you try each of these and see which one gives you the same number as this. But us, we already know how to simplify radicals. So what are the two factors of 20? Correct. 4 and 5. If you say 10 and 2, unfortunately 10 doesn't have a perfect square root. There is no number that when you square you get 10. So these are the two numbers. Okay, now square root of 4, 2. Square root of 5 doesn't have one, because there is no number that when you multiply you get 5. So then it stays at 2 radical 5. And now you know which one is your choice. Okay? Awesome. All right. Ones and twos, or it doesn't matter to me, so it shouldn't matter to you either. So now we're going to add, and negative 10 squared is 100, so we're going to do that. And of course, can you see? Yes, you can see. So 36 plus 100 is 136. Now, look at the choices. None of these choices says 136, so either you check with the calculator what number is this, and then check to see which one of this is the number. Okay, now 136 is kind of like close to 144, so it's close to 12. So therefore, this cannot be the answer. This cannot be the answer. So it's either this one or this one. All right. Now look, 161 doesn't have a number outside. So, and 61 is not the same as 136. So this cannot be. I know that the answer is going to be 1, but let's just check. So what do I do? Easy. Take the 136, okay, and divide by perfect squares to see which one gives you the right one. So 136 divided by the first perfect square that I'm going to divide is 4. Oh, wow. Look, already got it. 34 and 4. Okay, so this is nothing more than 4 times 34. The square root of 4 is 2, and 34 doesn't have a perfect square root, so it stays at 2 radical 34. And my suspicions were correct. And now you have quiz number 9. Okay, so it says in a circle whose center is 2, 3, one endpoint of the diameter is at -1, 5. So let me see if I have ink. No, -1, 5. This is 0, 0. Sorry. Okay, this is 0, 0. So -1, 5 should be -1, 1, 2, 3, 4, 5. It should be right here. Okay, -1, 5. The other endpoint, okay, of the diameter, I'm sorry, the center is 2, 3. The center of the circle is 2, 3. So it's 1, 2, then 1, 2, 3. Okay, so now if you have a compass, I'm going to show you something which basically they don't want you to do it like that. Ouch, 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 ouch. Ah. Sorry. Uh-oh, wrong compass. Really? Am I that bad? I am going to use the toy. Okay, let me see it. This toy works? Yeah, this toy works. Okay, so I could just, since this is the center and this is one point on the circle, that means that this is the radius. So all I gotta do is I will put my point here. I will do this. Yeah, I know it's cheating, but hey, you could do it. And I will just trace a circle like that. See that? So I already know where my next point is. So all I gotta do now is connect the point right here. See that? No, you cannot see it. Maybe you could see it like now. Okay, so that's what I did. Let me see. All right. So my next point will be right here. But anyways, let's be honest and let's figure out what this is. So the center is 2, 3. Okay, and they want me to find the coordinates of this other endpoint. Sure, why not? So all I gotta do is use the midpoint formula, but the variation of it. What do you mean the variation? Well, the midpoint formula is that you add the x's, right, and divide by 2, add the y's and divide by 2. Okay, that's to find the midpoint, but they want you to find the other endpoint. We already have the midpoint. So how am I going to do that? Easy. Use the variation to find the endpoints. Here you add, divide by 2. Well, in the other one you're going to multiply by 2 and subtract. For example, let us find the endpoint. To find the endpoint of x, okay, you multiply the midpoint of x by 2 and you subtract one of the endpoints of x. To get the endpoint of y, you multiply the midpoint of y by 2 and you subtract the other y component. Okay, let me try it. Of course. So let's try it. I'm going to try it on the grid right here. So 2 times the midpoint of x, which is 2, minus the coordinate of x, minus, what is the coordinate of x? -1. Minus -1. See what I get? 2 times 2 is 4. Minus -1, that's 5. Okay? Now let's try for the y, the endpoint of y. So 2 times the midpoint of y, 3, minus the other component of y, 5. So let's see, 2 times 3 is 6, minus 5 is 1. Now let's see if we were correct when we, wait, did I do it right? Well, 1 and 5. So the coordinates are, okay, the coordinates of the endpoints are going to be 5 for x and 1 for y. Let's see if it's true. So this is 0, 0. Okay, that's the union of the two. See it right? Okay, so this is 0, 0. So let's see, 1, 2, 3, 4, 5, and then 1. Guess what? The compass doesn't lie. The compass doesn't lie. And that's it for your quiz number 9. That's the end of the packet. So that's it. Okay. Thank you very much. Bye bye.